Kristen, we're all good on this side.
Great. Thank you so much, Tasman. All righty. I'm so excited to introduce our next speaker. Rosa Avalos-Warren is a human spaceflight mission manager, managing and overseeing concepts of operations, system requirements, pre-mission integration, operations, and post-mission evaluation. She supports the International Space Station, Commercial Crew Program, and the Artemis program. She does it all. Before joining the human spaceflight, Rosa worked as a project manager in launch and flight operations at NASA's Wallops Flight Facility, where she provided telemetry support as well as range support to Rocket Lab and multiple air surveillance, human exploration and operations mission directorate projects. And then prior to working at Wallops, Rosa worked for NASA's Johnson Space Center as a contractor, supporting the ISS program as a mechanical and operations engineer, and in addition to a multitude of other engineering and management roles. Back in 2009, she began working with NASA Langley Research Center, National Institute of Aerospace, and Virginia Tech on the Multidisciplinary Design Optimization Truss Braced Wing project. NASA has awarded her a number of awards, including the Space Flight Awareness Team Award for her work on restructuring ISS flight rules. Her STEM outreach abroad in the United States have earned her the recognition from former NASA Administrator Charles Bolden. And then outside of NASA, Rosa is a TEDx speaker, participates in the US State Department Outreach Program, and is a solar system ambassador, regularly talking to students around the world about the importance of science, technology, engineering, and math. She's earned her bachelor's degree in aerospace engineering from Virginia Polytechnic Institute and State University, and her master's degree in mechanical engineering from Rice University. Rosa, thank you so much for being here today, and we are looking forward to hearing from you.
Thank you so much, Kristen, and thank you to the Space Generation Advisory Council for the opportunity to be a speaker for this virtual event. It is certainly an honor to be with all of you today. Next slide. In a nutshell, the Space Communications and Navigation, known as SCaN, oversees the different components of NASA's communications and tracking infrastructure services. So the two primary networks are the Deep Space Network, known as the DSN, and the Near Space Network, known as the NSN. The different missions that are supported by SCaN use radio frequency to ensure that we can transmit data from different missions back to Earth. And an example of this is sending photos and videos that are taken from space. Next slide. More about communications and navigation. SCaN has satellite communication where we use government and commercial providers, also optical and quantum communications. In addition to that, we also have the search and rescue team. That support is provided to the different commercial crewed missions, as well as Soyuz missions and the future Artemis missions. SCaN also has the spectrum management, where it's important to identify the different parameters and frequencies, and as well as navigation. Next slide. For Deep Space Network, it is operated by the Jet Propulsion Laboratory. It supports mostly interplanetary spacecraft missions and has 3 different facilities, including California, Spain, and Australia. So the DSN also provides radar and radio astronomy observations that improve our understanding of the solar system and the larger universe. Next slide. As far as the Near Space Network, as a single end-to-end network, the Near Space Network provides different communication services, space links, and data transports for users. And so for the Near Space Network, we provide essential communication and navigation services for to different missions. And here we're talking about in the near space regions out to 2 million kilometers away. And so these services include government and commercial providers as well. Next slide. And just as an overview, overall, the support that is provided by the NSN last year, it included supporting 16 launches with 2 million direct to Earth services minutes and 10 million space relay services minutes. Next slide. Across NSN, we not only support missions for human spaceflight, but we also support different missions that are related to launch vehicles that support science and robotics missions, as well as tech demonstrations. And later on in the slides, I'll be able to go over the different human spaceflight missions that we support. Next slide. Okay, and just as far as, a little bit about myself, I work for the Near Space Network, supporting the human spaceflight missions. And so this means providing communication and tracking support to various programs, including the International Space Station, Commercial Crew Program, and Artemis. And my career related to NASA started back in 2009 when I was a student researcher with Virginia Tech and NASA Langley. And I have been lucky to have worked at different NASA centers, including Johnson Space Center and Wallops Flight Facility. And accounting for my past role as Mechanisms and Operations Engineer for the International Space Station, and now a Human Spaceflight Mission Manager for NSN, I've led more than 25 NASA missions. Next slide. Going into more details for our role within human spaceflight, it does not only involve cargo missions to the International Space Station, but also the different crewed missions. So ensuring robust communication services. And there is certainly never a dull moment. As we were getting ready last week and this week, not only did we support the multi-purpose laboratory module docking, the MLM docking to the International Space Station, but also the preparations for the Boeing Starliner OFT-2 launch and the upcoming Northrop Grumman launch, NG-16, which is scheduled to launch on Tuesday. Next slide. From a mission manager perspective, we support the missions throughout the entire life cycle. So we provide requirement analysis, communication analysis, different service agreements, mission design, mission planning, launch, operations, and also post-mission support activities. Overall, this helps ensure that all these missions have robust and reliable services that fully support the respective mission objectives. Next slide. For the International Space Station, we support the different increments, the different extravehicular activities, as well as the visiting vehicle support. And they go all from, launch, rendezvous, and return to Earth. We certainly have a strong team and coordinate these different services with the Flight Dynamics Facility, the Search and Rescue Team, as well as the Space Force. For the Commercial Crew programs, we work closely with SpaceX and Boeing, working side by side to ensure that we're meeting NASA's requirements. And a lot of you may have been familiar with the launch of DM2, and as well as the different SpaceX Crew 1 and Crew 2 missions that have been supported by our team. And last but not least, we're gearing up towards supporting supporting Artemis and its different components, including Orion and the ICPS, which is the Interim Cryogenic Propulsion Stage. So we aim to provide critical support to these missions during launch, orbit, and return. And we're leveraging all of the efforts and all of the different lessons learned from the International Space Station and also the Commercial Crew Program to support Artemis and to make sure that we're ready for Artemis 1 and on. Next slide. And from a communications perspective, we have different milestones that use the Near Space Network as well as the Deep Space Network. So when we're talking about the various phases of launch, low Earth orbit, and ICPS separation, we're using a combination of the tracking and data relay satellites, as well as the launch communications segment. There will be a handover between the TDRS satellites covered by the Near Space Network, and that will pass communication services to the Deep Space Network. So as Orion is on its way to the moon, the Deep Space Network as a primary, as well as the Near Space Network ground station as a supplementary asset, will be providing tracking and navigation data. When Orion arrives at the moon, It will enter a distant retrograde orbit where NASA will continue to test Orion's capabilities. And so as it gets ready to return from the moon, the DSN as primary and NSN as supplementary will be supporting the return transit. And during the return trajectory, the Orion vehicle will safely enter Earth's atmosphere, and the NSN will join the DSN and take over the communications for the rest of the mission. And so we'll be using teeter satellites to support the different re-entry and splashdown and recovery of the Orion vehicle for Artemis 1. More about LunaNet also. LunaNet is NASA's plan to bring internet-like networking capabilities to the moon. And so it will enable the Artemis program while providing a platform for NASA to build out network services further into the solar system at planets such as Mars and Venus. So with LunaNet in place, users will experience an operational environment similar to that experienced by internet users here on Earth. We'll leverage all the support provided to the International Space Station program, the Commercial Crew program, and the Artemis missions to make sure that we prepare ourselves to humanity's journey to Mars. And so as we experience the Perseverance rover launch in July of 2020 and the landing earlier this year in February, we're learning more about the red planet and how we can make life sustainable. This is why it's important to consider essential resources such as oxygen, water, shelter, touchdown spacesuits that our astronauts will use in the future. Next slide. And here are different sources as to how you can connect with us. You can use these websites and social media sites. But after this presentation, we have a video for all of you.
Sorry, I just got the note. There's no audio, so give me 1 second.
In 1972, America launched 9 human missions to the moon, 6 of which successfully touched down, allowing 12 men to walk on the lunar surface. NASA's next chapter of lunar exploration, called Artemis, has the task of not just going to the moon to create a long-term human on and around it, but also to prepare for ever more complex human missions to Mars. In short, everything we must be able to do here, we must first do here. So, what will an Artemis mission look like? Everything is designed and tested with our most important element in mind, the astronauts. This is their deep space, human-rated spacecraft called Orion, built in 3 parts. The crew module, where up to 4 astronauts will live and work throughout the flight. The service module, with life support systems for the crew and its own engine and fuel reserves. And a launch abort system, with engines capable of pulling the crew module to safety during launch should anything go wrong. To accomplish the task of launching our crew and heavy payloads, NASA is building the Space Launch System, comprising of a cargo hold, an exploration upper stage, a massive core stage, and 2 extended solid rocket boosters. Altogether, this is the world's most powerful rocket, and it exceeds the legendary Saturn V of the Apollo era in numerous ways. Sitting on the launch pad, the entire rocket, fully fueled, weighs just over 6 million pounds, 5.2 million of which is just the fuel. Once ignited, there is no stopping what comes next. All four RS-25 engines and the 2 solid rocket boosters come to life, thundering our crew upwards. 2 minutes after ignition, the solid rocket boosters are spent and released. 8 minutes after launch, the core stage is depleted and separated. The upper stage fires briefly, placing Orion into a parking orbit around the Earth. Here, the crew reconfigure the spacecraft and check systems to confirm everything is ready for deep space travel. With a go from mission control, the crew reignite the exploration upper stage engines to leave Earth entirely. The exact timing of this maneuver is critical to reach a speed that can escape Earth's gravitational pull, but also put Orion on a course that will intersect the Moon days later. Once this burn is complete, the upper stage of the SLS is jettisoned and the crew aboard Orion coast for several days toward all that awaits them at the Moon. Approaching the Moon, we see the fundamental differences between Artemis and Apollo. Instead of requiring Orion to serve as an expendable lunar command module or to carry a constrained lunar lander, the Artemis missions will take advantage of a different approach: pre-staging. Everything needed for lunar missions will be positioned in advance by commercial and international partners. This includes rovers, science experiments, and human-rated systems on the surface. But it also includes a dedicated lunar station in orbit around the Moon called Gateway. Here at this station, we can pre-stage a robust lunar lander and establish a strong communications relay. Designed with open standards, the Gateway can be expanded as new missions and partnerships develop, allowing multiple human missions on the Moon at the same time and enabling ongoing science to be conducted even between human missions. The Gateway is also capable of adjusting its orbit to allow access to every part of the Moon, something the Apollo missions could not do. But the real key in this approach is placing Gateway in a unique halo orbit to perfect the maneuvers needed for Mars missions. And with the growing list of commercial and international opportunities, Gateway is the ideal hub between Earth and all that lies beyond. Returning to our crew as they approach Gateway, the Orion must match the elliptical orbit of the station in order to successfully dock. Once on board, pre-selected crew members transfer to the lunar lander, while those assigned to Gateway remain on station. The lunar lander system itself is built for 3 unique steps: descending from the halo orbit of Gateway down to a low lunar orbit, descending from low lunar orbit to the surface, and once the lunar mission is complete, launching from the surface of the Moon and ascending all the way back to the orbiting Gateway. Once back aboard the Orion spacecraft and undocked from Gateway, the crew fire their engine once to break out of the halo orbit and once again to sling the spacecraft around the Moon, placing it on a multi-day trajectory back towards Earth. As they near the end of this journey, the service module is released, and the crew module is oriented heat shield first. Entering Earth's atmosphere at 25,000 miles per hour, the friction of air slows Orion considerably, while also subjecting it to temperatures of 5,000 degrees. With the Orion now at just 300 miles per hour, a series of parachutes uniquely tested and produced for this moment deploy, decelerating the craft to just 20 miles per hour for splashdown. With each successful mission, Artemis ushers in the next wave of men and women to explore our Moon and prove that together we are ready to go beyond.
Thank you so much for listening to my presentation and also watching the video. I think now it's a good time to start the Q&As.
I suspect Kristen's working out her audio here. I had one question I saw written in the chat somewhere. Are you guys hiring? What kind of job opportunities are there with SCaN right now?
Yeah, so I always encourage everyone to visit the USA Jobs website and also the internship.nasa.gov website, because there are different job positions that come up and they have a timeline that they follow, and then they have to retire that advertisement. But always encouraging. It really is very sporadic, and it comes up. And so I will say, just make sure that you keep yourself updated via those websites.
Thank you, Rosa. I hope everyone can hear me now. That was a wonderful presentation, and thank you so much for sharing that video with us. It looks like everyone is really excited about being a part of the Artemis generation. So we'll go ahead and take some questions from our audience. Roxy Williams, go ahead.
Thank you, Kristen. Thank you so much, Rosa, for the presentation. It was amazing and really exciting for me to be part of the Artemis generation. I have a really quick question, and the question is, from your experience and expertise, what do you think will be some of the challenges regarding communications when it comes to developing the Artemis project or mission?
Yes. So as we're working forward with the Artemis mission, we are already taking into consideration, the different knowledge that has been gained from the different missions. Of course, it is something that, because it is a quite a distant type of mission in terms of, going back to the moon. There are different resources that are going to have to be taken into consideration that are already, we're already going through the different simulations from a communications perspective with the Near Space Network and the Deep Space Network. And so one of the things I think that now what we're going to have to look at is, as far as the communication, how we're going to jump from the moon and then go to Mars. And one of the aspects that, the different types of projects that are being looked at, that is a really good example of how we're trying to make communication more, reliable overall, is via the LunaNet that I spoke about earlier, trying to make sure that we have that infrastructure to be able to connect, from the moon and be able to connect back here on Earth in terms of, or even when we go to Mars and connect, in a faster manner. And so all of these different projects, not only LunaNet, but there are different, optical type of communications that are being researched and projects that are being leveraged, that I think there needs to be more research into that to make sure that, we have the different capabilities to take us, from the moon and then to Mars.
Thank you, Rosa. We have a question from the chat. I'll go ahead and read it from Aaron Garduño Rodriguez. Thank you for the good presentation. A question for you. What will be the delay time in communications between the moon and the control center on the ground?
Yes, and so that's usually something that is being, evaluated. And why I'm saying that is because, even from the Apollo missions and now to the Artemis missions, it is something that is a work in progress and something that we're trying to make sure that we are, becoming more and more efficient on. And so not necessarily, I cannot tell you like a concrete time frame, because that is changing, and there's infrastructure that is going to be changing continuously. And so that is going to be, a kind of a work in progress and kind of a changing time as well.
Absolutely. Thank you. All right, next up, Julio Hernandez.
Thank you, Rosa, for sharing your time to be here for us today. I had a question about what is the planned broadband capabilities expected to be provided by the Gateway or LunaNet?
Julio, can you repeat your question one more time, please?
Yes. What is the planned broadband capabilities expected to be provided by Gateway or LunaNet? Basically, will we be able to expect 1080p footage or 4K footage off of the surface of the moon?
Mm-hmm. No, certainly a good question. And the thing that we need to think about in terms of how we're moving forward with all of these projects, just in general. I mean, just as LunaNet is enabling the Artemis program and providing, that type of platform, the different missions that are also taken into consideration is not only, thinking about it from an Artemis perspective, but also from, how this is going to take into consideration for, you mentioned it pretty well, not only Gateway, but also the robotic landers, right, rovers, and also trying to find out, how we're going to be providing that type of capability. But LunaNet in general will also support the PNT services. And so what that will allow for is a more precise surface operations, and then also science, and bringing back that type of data in order for us to stay, and for the astronauts, whenever they're going to be landing in the future Artemis programs, be able to have more real-time type of alerts that are generated from, for example, for space weather instruments, or different types of, space activities that are happening.
Thank you for your insightful answer.
All right, we have time for just a couple more questions. So next up, we'll hear from Yashraj Patil.
Yeah, hi Rosa. That was a great presentation from you. My question is like, have you guys considered the quantum communication for the real-time and the spatial part of the data transfer in the upcoming Artemis mission?
Just to make sure, are you asking if we're looking at quantum communications?
Yeah, exactly.
Okay, so certainly quantum communications is something that is on the agenda, but one of the things, just like what we use for the International Space Station and for the Commercial Crew Program, we have the National Space Quantum Laboratory Program that is also known as the Quantum Technology in Space. And so what that does, it uses laser systems on the International Space Station. And so that exchanges quantum information between two devices on Earth without a physical link. And so we're talking about a refrigerator-sized module that will be attached to the outside of the space station and will generate the entangled photons that carry the quantum information to Earth. And so I would think that similar capabilities that we're trying to use for the International Space Station, it's something that maybe as we gain more experience with, we'll be able to use that type of capability, for Artemis and future missions.
Yeah, thank you for the answer.
Thank you. And this, unfortunately, will be our last question. Grant Kendall-Bell, go ahead.
All right, thank you. Hi, so I'm Grant. My question was also about laser and quantum communications. And since that's been touched on a little bit, I'll evolve my question. I'm curious, what do you anticipate is the timeline for optical and quantum communications to be used regularly in, I guess, in cislunar space? And what do you think are the most important use cases for that?
Mm-hmm. So I'll speak a little bit more about other projects that relate to that. As far as the timeline, for example, we have between 2021 and 2022, we have the laser communications relay demonstration. And so it is such a unique project because it provides capabilities of optical communication using infrared lasers to send and receive data. And we're not only talking about that, but just optical communications in general, providing significant benefits for missions, right? Including data rates that are 10 to 100 times higher than comparable radio frequency systems. So in general, with LCRD, demonstrating the data rates of 1.2 gigabits per second, faster than most Americans experience through their high-speed internet links, is such a fantastic project, and overall effort. And also, touching on that, we not only have the LCRD, but for Artemis 2, we have the optical communication system, which is known as the O2O, and that will provide Orion with data rates as much as 10 times higher than possible through its current system. And so there are different projects that are already taking, that are in work that, I can see that in the near future. Of course, we're very and quite focused on Artemis 1, but there are different projects that are going to be used not only for the International Space Station, but, in the future, we'll make sure to use, after we definitely get experience and apply that to missions such as Artemis and on.
Awesome, thank you.
Well, thank you so much, Rosa. Your talk was absolutely delightful. Again, I am just so excited about the upcoming future for Artemis and all sorts of fun stuff coming up. So thank you again, and we really appreciate it. So
thank you so much, Kristen. Thank you. And thank you to everyone. And all your questions were, were great. So thank you for the opportunity.
Thank you again. So in fact, we actually have another treat for everybody from NASA SCaN. We're going to move over to a Gather Town session sponsored by NASA SCaN. We're all going to get together using our little tiny 8-bit avatars. It's a really fun way to network